Let's talk about how to use the EaganMatrix Eurorack module, though you could do this with any of the EaganMatrix instruments, to support a 4-voice microtonal output using the control voltage converter, the CVC, with MPE input and Osmos MPE control. In short, the EaganMatrix module with CVC can support MPE-to-CV conversion. Let's take a look at basic connections. Now, the current CVC model is a standalone external unit, but Haken Audio is coming out soon with a native Eurorack version of the CVC that will allow you to plug it right into your rack next to an EaganMatrix module to have a very integrated environment. The new CVC is identical in function to the old one, identical in terms of how you connect to it. It's just Eurorack based. And of course you can see its connectors are more concentrated now, but they're the same 4 sets of W, X, Y, and Z CV outputs that the older CVC supported. There's also an option now to connect a second CVC, both with the older unit and this new one, to support 8 channels of W, X, Y, and Z output if you need that. The connection to the CVC is the same as before. With some instruments you'll connect using a TRS connection to get your I2C output into the CVC. Other options will allow you to connect to the CVC with a 5-pin MIDI connector. You can see all of the Haken Audio and Osmos instruments support connections to a CVC. Continue Mini, EaganMatrix Micro, Thin Continuum, and the EaganMatrix Module all connect up using a TRS connection to the TRS port, the I2C TRS port on the CVC. The older Thick Continuum connects with a 5-pin MIDI DIN connector, as does the Osmos. This has to be full 5-pin because the unused pins in the MIDI connector, the 2 unused pins, are what are used to transmit the I2C data the CVC needs to operate. And just like the older unit, if you want, once you send your MIDI data, you can pass it through as well. So let's take a look at a setup. Of course, there are many possibilities here. This is just one I put together that allows you to see how to use all 4 sets of W, X, Y, and Z outputs of the CVC in a Eurorack configuration. So we have the EaganMatrix module, and I'm going to send MIDI data to that. In this case, we'll use an Osmos set as an MPE controller, DIN out of that to a TRS adapter that'll send the MIDI data to the input port of the EaganMatrix module. I'll connect up through the USB port a computer that will allow me to configure the CVC, and in this case I'm going to configure the CVC for polyphony 4, and I'm going to use Portamento Glide at a major second for this example. To do this in a microtonal environment, I'm going to need some way to download a microtonal tuning grid to the EaganMatrix module. I can do that with the pitch table editor or the Electro 1 MK2 retune application I wrote that will allow you to create and download microtonal tuning grids. So we have the connections to the EaganMatrix module. I'm not going to use the audio output or audio input of the module. I'm not going to use CV inputs to the module. Everything will be done, in this case, through MPE that will be translated to CV. So the MIDI out connector on the Eurorack module will set that to its I2C output option and connect that with the TRS cable to the CVC. And now any MPE data that I send to the Eurorack module is going to be translated into CV data. Once I have the CVC connected, then I can start connecting things to my Eurorack setup. In this case, I'm going to use a Synthesis Technology E370. This is a quad morphing VCO. It will allow me to play 4 voices in parallel. I'll set them in this case to a simple sawtooth configuration. So what I'll do here is I'll take the X 1 volt per octave outputs and I'll put those into the 1 volt per octave inputs of this 4-voice module. I'm going to want to use key pressure, my MPE channel pressure, as the envelope control here. So what I'll do there is I'll take the Z pressure outputs and I'll put those as the CV inputs to a quad VCA. I don't need gating here because my VCA is going to use the Z inputs directly to control the envelope of the output. Then what I'll do is I'll take the audio outputs of the VCO and I'll put those as inputs to the VCA. And now the output of the VCA, with the right settings that I'll set, will be envelope controlled, and I'll send the 4 channels of VCA audio into a mixer, and I'll send that into, in this case, a Strymon effects processor, but you could use any effects processor you like, and the output of that I'll just send to an I/O card to send out. Relatively simple setup, but I'm using all 4 channels of my CV to control 4 separate oscillators. They just happen to be in the same card in this case. Now you might ask, okay, that's one possibility. What if I have envelope generators and I want to use that instead? Well, in this case, you can get rid of your Z outputs and send your W gates into an envelope generator, and that can be used to control the VCA envelope. So you have a lot of options. The main thing here is that the MPE input will be automatically translated to 4 channels of CV, which is a great option to have the EaganMatrix module function as an MPE to CV converter. Not many things out there can do that. I didn't show that I can also connect up the Y outputs if I have something that can make use of them. In this case, this module, for example, has FM inputs that I can modulate some of the oscillators using Y if I want to do that. So that's up to you. Now, of course, if you want to use an instrument connected instead of an Osmos, no reason why you can't do that, or a Rolly or some other MPE controller, perfectly fine. One thing we're going to want to make sure is if you have oscillators connected to this setup, go in and using the scope or however you can fine tune an oscillator, make sure your oscillators are as close to the played pitch on your instrument, be it the Osmos or instrument or whatever, as you can get, because we're going to be using micro-tuned offsets here, and if you're not dead to nuts tuned in to your frequencies, you may get unexpected output. In this case, I have coarse and fine-tuning adjustments that I can make, and I'll check each one of the 4 voices connected to my scope to make sure they're okay. I like the data scope that lets you put an input in and get the output there, so I can always go back and recheck my tuning on each of the oscillators. And here you can see I have set up where I'm in the morph XY mode of each of these oscillators set to a default sawtooth wave. So in this case I can send in both X and Y to create morphing. In this case I'll just send in some Y to create some modulation. The last thing is, as before, make sure your priority is set to low in your preset. This way you can predict which note you're playing will be output on what CV channel. In low priority, the lowest note you press will always come out as the lowest of the CV channels. So if I press 1 note, it'll come out in channel 1 on the CVC. If I press 2 notes together and I programmed polyphony, you'll get channels 2 and 3, etc. This can be important, of course, in situations where each one of your CV outputs controls a different sound. You want to be able to predict what you press maps to what sound comes out. And finally, I've set this CVC configuration for its default 0 to 10 volt output for both Y and Z. You can set it for 0 to 5, You can program it for any intermediate voltage as long as it's between 0 and 10 volts. And you can program, of course, -10 to +10 if you need to have bipolar CV outputs. Okay, so I have the Osmos connected, and I also connected a instrument up to my iConnectivity Mio XM that will allow me to route them both together. So I have my setup as described in the presentation, and I've set things up, at least right now, for standard equal temperament. And you can hear I have the pressure glide set, the pressure portamento set. In the EaganMatrix, I don't set it on the Osmos, and again, I don't even have that function on the instrument. It automatically takes the MIDI notes and applies them, giving it pressure portamento to the interval that I assigned. I have the 4 oscillators set, tuned up so that I can play up to 4-voice polyphony. And on any given note, the pressure glide will kick in. So you have a combination of both. If you want the pressure glide, you slide between notes, articulate them, and then no pressure glide. Okay, all well and good. Now let's set some microtonal operation. I have my Electro One tuning app. Let me just set a knock-on here. And of course you can get your vibrato in. And obviously, I've reset things here for tuning. I can set some other tuning in. Here, let's set something that's like a 15 EDO, say. You're not going to get an octave every 12 notes now. You get an octave every 15 notes. And now I can get my full micro tuning. Of course, playing it on a keyboard, you'll have to rearrange your thinking in terms of how 15 EDO plays. This is why an isomorphic controller is better. And here you can hear my pressure glide kicks in on those notes. And you can go and play however you like in your new tuning, or set things back to equal tuning if you like. One of the nice things about my MK2 Electro One app is that it sets tunings pretty much instantly versus the pitch table editor, which takes a minute or so for it to download the tuning. And we can just set it right back. That's it. If I have my system tuned well, I can set my micro tunings, load up the pitch tables, and you're in business. And the EaganMatrix module will take care of mapping your microtunings to the right MIDI notes. It'll also take care of mapping your MPE to CV, and you can create all kinds of interesting combinations of things and, of course, great compositional output this way.